Okay, so today we're starting 4.6. This is day 1, and it's about inverse trigonometric functions. So our goal for today is that we can evaluate inverse trigonometric functions. So recall we learned this in pre-calc here in lesson 1.7. We learned in order for a function to have an inverse which is also a function, it must be 1 to 1. Remember, this means it would have to not only pass the vertical line test, making the original function, but it would have to pass the horizontal line test. So if horizontal line test, let me write it down first before I start talking again. So if you have a relation and it passes the vertical line test and the horizontal line test, then it is a one-to-one function. Okay? So because of this, the sine function, cosine function, and tangent functions they all fail the horizontal line test, therefore they're not one-to-one. So really quickly, let's look at Desmos here. I have tangent in there, but let's do y equals, and we'll do sine first. Sine of x, and this is what it looks like. So if you look, this passes the vertical line test, therefore it's a sine function, but it doesn't pass the horizontal line test, so it's not one-to-one, therefore it's inverse if we just took the whole thing as not a function. And we're talking about inverse functions today. So what we have to do is we have to restrict the domain so that we're only looking at a piece that is one-to-one. So what we're going to do is if you look at from here to here, those 2 points that I just hit, that if I look in between those two, if you look in between those 2 points, it passes the vertical line test and it passes the horizontal line test. So that's what we're going to restrict sine to. All right, let's go back to notes here. Okay, so there's what sine looks like. That's the restricted piece that we're going to use. Okay, so it's from here to here. We're using this piece right here. If you look at the limited domain, it goes from, this is negative pi over 2 because it's halfway in between negative pi and 0. And this is pi over 2 because it's halfway in between 0 and pi. All right, so the range would be all values in between the domain. The domain would be all values in between negative pi over 2 and positive pi over 2. And notice there are values at pi over 2 and negative pi over 2, so I'm including them using brackets. My range, the lowest it goes, let me highlight here, the lowest it goes is -1, the highest it goes is 1. So all values in between -1 and +1, including both. Now, that's the sine function, okay? Now, since we are doing the inverse, remember for inverse, you switch x and y's or you switch domain and range. So, our inverse function's domain is going to be, I'm going to switch this. The domain would be -1 to 1. And the range is negative pi over 2 to positive pi over 2. So this is the real important part right here. The range is negative pi over 2 to pi over 2. So if I ask you for the inverse sine inverse of a function, the input that I give you has to be in between -1 and 1. So meaning that I can't say sine inverse of 6. It has to be a number in between -1 and 1. And you always have to give me an answer in between negative pi over 2 and positive pi over 2. Right? Now, because angles and arcs given on the unit circle have equivalent measures, the inverse sine function is also referred to as arc sine. So we're going to use both. We're going to use sine inverse, which looks like so, and we're going to use arc sine, which looks like so. The reason we're doing both is because I don't only want to teach you one and then you see another on a standardized test and be like, oh, I don't know how to do that. When if I teach you both, you know how to do them. So they're the same thing. So when I ask you for, oops, I was highlighting, not scratching out. If I ask you for sine inverse of 1/2 or arc sine of 1/2, I'm asking you for the same thing. Now, what am I asking you for? Okay. We are looking for angles. When we're looking for sine inverse, cosine inverse, arc sine, arc cosine, we're always looking for an angle. So we are looking for the angle that has a sine of 1/2, and your answer must be in between negative pi over 2 and positive pi over 2. okay? So let's try a few of these because I've done some talking but no examples so far. Okay, so this says find the angle that has a sine of 1/2. So it says, what it says on paper is sine inverse of 1/2, but what it actually, when I think of it, it says find the angle that has a sine of 1/2. Now, what I have to remember is that sine inverse is only located from negative pi over 2 to positive pi over 2. So let's actually draw that up right here first. When we talk about that, if I have my 4 quadrants drawn right here, think about where pi over 2 is. Pi over 2 is here. Think about where negative pi over 2 is. Negative pi over 2 is right here. So all of my angles have to be from negative pi over 2 to positive pi over 2. So the only answers I can get is anything in the first quadrant. Let me change colors here. So we have pi over 6, pi over 4, pi over 3, pi over 6, pi over 4, pi over 3. We have 0 radians. And then we have these 3 angles, which are negative pi over 6, negative pi over 4, and negative pi over 3. And then we have these 2 angles, which is pi over 2 and negative pi over 2. So those are your only possible answers. No other answer is possible. So if you gave me an answer other than this, it's incorrect for sine inverse. All right, so let's go ahead and try this one here. So sine inverse of 1/2. What angle has a sine of 1/2? So I have to say to myself, which 2 quadrants is sine inverse defined in? The first and the fourth. Okay, so then I say, okay, where is sine positive? The first quadrant or the fourth quadrant? Sine is positive in the first quadrant. So my angle is in my first quadrant. So I'm looking for the angle in my first quadrant that has a sine. Sine is the y value of 1/2. So what is that angle? Now, some of you might be saying, oh, it's 30 degrees, right? But remember, my answer has to be in radians. So we're not going to say 30 degrees. Instead, we are going to say pi over 6. All right, let's try another one. Arc sine, which is the same thing as sine inverse, of negative root 2 over 2. So what angle has a sine of negative root 2 over 2? So first off, I say sine inverse is only defined in my first and fourth quadrants from negative pi over 2 to positive pi over 2. Where is sine negative, in the first quadrant or the second quadrant? The answer, sorry, that's the fourth quadrant. The first quadrant or the fourth quadrant? The answer is the fourth quadrant. So my angle's in this quadrant. Remember, sine is a y value. So I want to know what is this angle. So if you have to fill in the ordered pair, you can. You know this is root 2 over 2, negative root 2 over 2. That's a 45-degree reference angle. Okay? But it's in a negative direction, and it has to be in radians. So my answer is negative pi over 4. All right, I want to know which angle has a sine of 1. So once again, sine inverse is defined only in my first and fourth quadrant from negative pi over 2 to positive pi over 2. So I want to know which angle or what quadrant am I in. So now, first thing I say is, wait a minute, this is 1, right? My sine, my y values, that's not in a quadrant. That is at a quadrantal. So I want to know, is it here, here, or here? Is it at positive pi over 2, negative pi over 2, or 0? So remember, I'm asking for where the y value is 1. So what I like to do is write down all of my ordered pairs here. So I have, this is 0, 1. This is negative 1, 0. And this is 0, negative 1. So if you look, this y value is 1. This one's 0, and this one's negative 1. So my y value is 1 right there. And what angle is that? That is pi over 2. All right, last one. This is multi-step. So first, I have to work inside the parentheses. So I'm going to do this first. What angle has a sine of 1/2? Now, instead of doing this again, I'm going to look right here. I already did that right here, right? It's pi over 6. So now I know that's pi over 6. So now I'm going to take the sine of pi over 6. So what is the sine of pi over 6? Remember, pi over 6 is 30 degrees. The ordered pair is root 3 over 2, 1/2. The sine is the y value. So the answer is 1/2. Now another way of looking at this is that sine and arc sine are inverses of each other. Sine and sine inverse are inverses of each other. What do inverses do to each other? If I add 6 and subtract 6, or I multiply by 5 and divide by 5, We say they cancel each other out. So realize that's another way of looking at it. All right, let's look at cosine here. So this is what cosine looks like. It looks very similar to sine. But notice I cannot restrict this from negative pi over 2 to positive pi over 2 because it does not pass the horizontal line test. So instead, we restrict cosine from here to here. If we restrict it from there to there, that piece right here that I'll highlight in blue passes the vertical line test and the horizontal line test. If you look at the domain of that piece, it goes from 0 to pi. If you look at the range of that piece, it goes from -1 to +1. Now, that is the restricted domain of the cosine function. I want the restricted cosine inverse function. So we're going to switch x and y. So we're going to switch the range and the domain. So my domain is in between -1 and 1. And my range is in between 0 and pi. What does this mean? The very important part is knowing this. Okay? So if I give you cosine inverse, I can only say cosine inverse of, and then it has to be a number in between -1 and 1. So if I said cosine inverse of 6, it is not possible. If I give you a number in between -1 and 1, you're going to have to give me an answer in between 0 and pi. So if you think about where 0 is right here, pi is right here. So all of your answers are in between 0 and pi. So my possible answers are 0, pi over 6, pi over 4, pi over 3, pi over 2. And then notice these are positive answers. So you want your positive angles right here, not giving me negative answers. So if I ask you cosine inverse of blank, you can only give me a positive answer. No negative answers for cosine inverse. Okay, so this is 2 pi over 3 because that's my pi over 3 reference angle. This is 3 pi over 4 because that's my pi over 4 reference angle. And this is 5 pi over 6 because that's my 5 pi over 6, or my pi over 6 reference angle. So those are the only possible answers. Okay, so let's try one here. Our cosine, which is the same thing as cosine inverse of root 3 over 2. So I say to myself, which two quadrants is cosine inverse defined in? And that's quadrants 1 and 2. All right, where's cosine positive? Is it in the first quadrant or the second quadrant? First quadrant. So my answer has to be in this quadrant. Cosine is the x value. So this time the x value is root 3 over 2. What's that angle? A lot of you are probably saying 30 degrees, but remember I want my answer in radians. So my answer is pi over 6. All right, next one, cosine inverse. I want to know which two quadrants is cosine inverse defined in. The answer is 1 and 2. So now cosine is my x value. I want to know where is my x value 1. Remember that is at one of my quadrantals, so I have to know if it's here, here, or here. This is 0. Sorry, that's not 0. That's -1, 0. This is 0, 1, and this is 1, 0. So where is my cosine or my x value 1? It's right here. What radian measure is this angle right here? That is 0 radians. So my answer is 0. All right, next one. Cosine inverse of negative root 3 over 2. First thing I say to myself, where's cosine inverse defined? That's quadrants 1 and 2. Where's cosine negative? In the second quadrant, not in the first quadrant. And it's where is cosine negative between those two quadrants? I'm only looking at those two because that's the only place it's defined. So I know my angle's in the second quadrant. Cosine is the x value, so negative root 3 over 2. So I know that that's a 30-degree reference angle. So I want to know what's my 30-degree reference angle in my second quadrant. Remember, 30-degree reference angles are my pi over 6 angles. So that would be 5 pi over 6. All right, last one. Notice this is cosine and arc sine, which they do not cancel each other out. So I can't just say, oh, they cancel, it's 1/2. So first I have to do this. The angle that has a sine of 1/2. Okay, so I could look up and see what it is. Instead, I'm going to practice again. I know sine inverse is defined in the first and fourth quadrant. It's positive in the first. Sine is the y value. That's a 30-degree reference angle, so this is pi over 6. So now I want to know the cosine of pi over 6. So I want to know the x value. What's this value right here? That is root 3 over 2. So the answer is root 3 over 2. Okay, next we have tangent. Okay, so that's the only, and then we'll summarize. All right, so tangent looks like so. Okay, so if I said, and it keeps going on that pattern forever and ever, so this actually looks like this, and this actually looks like this. But if you look at it right now, it's not passing the horizontal line test. So I need to make sure that it does pass the horizontal line test. So I need to restrict my domain. So if you look, if I just look at this piece right here, that piece is 1 to 1. So what's the domain of that piece? Now, notice these right here are asymptotes. Okay, so my graph glides along that, and it glides along this but never touches it. So my domain is in between negative pi over 2 and positive pi over 2, but not including either because those are asymptotes. My range, the lowest my graph goes, is an arrow pointing down, so that's negative infinity. The highest is positive infinity. All right, so I want the tangent inverse, so I'm going to switch domain and range. That's negative infinity to positive infinity. And my range is negative pi over 2 to positive pi over 2, but it'll never be that answer. Okay? So what's the important part for you to know? I can ask you the tangent inverse of anything I want because it's negative infinity to positive infinity, but you can only give me an answer from negative pi over 2 to positive pi over 2. So think about what that means. Negative pi over 2 is down here. Positive pi over 2 is over here. So you can only give me angles in the first and fourth quadrant. So my answers can be, let me change colors here to red. It could be negative pi over 6, pi over 4, or pi over 3. It can be 0. It can be negative pi over 6, negative pi over 4, negative pi over 3. But it cannot be negative pi over 2 or positive pi over 2 because the function's undefined there. So notice that's why we have parentheses here. So that will never be my answer. All right, let's give this a shot here. So first off, this is tangent inverse. I say, where is tangent inverse defined in? Once again, it's quadrants 1 and 4. So to summarize, sine inverse is 1 and 4, tangent is 1 and 4, cosine inverse is 1 and 2. All right, so now I want to know where my tangent is 1. Remember, you have tangents memorized. Okay, that's what you have to remember. Tangents are memorized. Tangent of 30 degrees, which I'll put pi over 6 instead, is root 3 over 3. Tangent of 45 degrees, but I'm going to put pi over 4 instead because this has to be in radians, is 1. And the tangent of 60 degrees, which is pi over 3, is root 3. So you have tangents memorized. So if it's not this, if it's not this, or this in here, then that means it's one of my quadrantals. Okay, so let's give this a shot here. I want to know where tangent is positive. Tangent's positive in my first quadrant. So now remember, tangents I have memorized. What's the angle in my first quadrant that has a tangent of 1? Pi over 4. All right, next one. Arctangent is the same thing as tangent inverse, which is defined in the first quadrant. I want to know where my tangent is 0, and I say, wait a minute, I don't have 0 memorized as a tangent. I have root 3 over 3, 1, and root 3 memorized. So then I have to say, okay, that has to be one of my quadrantals. Is it this, 0, 1, this, 0, negative 1, or this, 1, 0? Now, you might be saying to yourself, wait a minute, didn't you say that this can't be the answer and this can't be the answer? So, yeah, this is out and this is out. But why is it out? Because it's y over x. Negative 1 over 0, undefined. 1 over 0, undefined. Y over x, right? This is y over x, 0 over 1, which is 0. So that is my angle. What is this angle in radians? It's 0 radians or 0 degrees. All right, next one. Where's tangent inverse defined in? The first and fourth quadrant. Where is it negative? The fourth quadrant. What angle has a tangent of root 3? We know that's 60 degrees, but remember it's a negative angle, so it's negative, and then we want it in radians, pi over 3. All right, last one, remember, we have to work from the inside out here, so we're going to do this first. Cosine inverse, which two quadrants is it defined in? 1, and 2. That's positive. Where is it positive? First quadrant. Cosine is my x value, root 3 over 2. So what's that angle? That's 30 degrees, or pi over 6. So now I want to know what's the tangent of pi over 6. I have my tangents memorized. That's root 3 over 3. Okay. All right, let's summarize this and then do a little bit of calculator work here. So, what I want to summarize here is the range summary, what answers you can give me. So for sine inverse or arc sine, you can only give me answers from negative pi over 2 to positive pi over 2. So that's the first and fourth quadrant. So that means that sine inverse is only defined in this quadrant and this quadrant. And if it's sine inverse of a positive number, it's in the first quadrant. Sine inverse of a negative number, it's in the fourth quadrant. Cosine inverse is defined in my first and second quadrant. So in between 0 and pi. So cosine inverse is defined in this quadrant and this quadrant. And it's negative in this quadrant. So if I give you a negative number, it's in that quadrant, positive in this quadrant. And then last but not least, I'm trying to color code this here. We have tangent. Tangent inverse or arctangent is only defined in my first and fourth quadrants from negative pi over 2 to positive pi over 2. But those two will never be your answer. So tangent inverse, if it's positive here, first quadrant. If it's negative here, fourth quadrant. Okay. This means that the angles that you're searching for will always be within the indicated range for the given inverse function. So notice if I ask you, what quadrant is this in, right? 1, 2, 3, or 4? 3 is a terrible answer. It'll never be in 3. But if I ask you what quadrant this is in, you can say, okay, sine inverse is defined in the first and the fourth quadrant. Where is sine positive? The first quadrant. So this is in the first quadrant. This is just extra practice that I'm adding to it because it's good to know. Then we'll put these in our calculator. Tangent inverse is defined in my first and fourth quadrant. Where is tangent negative? In the fourth quadrant. So this is in the fourth quadrant. Okay, so think about, that's a good practice to think about. All right. I just want to make sure we know how to put this in our calculator. So I'm going to go into my Chrome here, get it loaded. No thanks. Okay. So this first one here says, I should have split screen, but I didn't. That's arc sine of 0.3. Arc sine of 0.3. So first off, it's really important, this question right here, what mode are we going to be in? Okay. Remember, our answers are in radians. We want them in radians, so we're going to be in radian mode. So if your calculator is not in radian mode, you have to move it to radian mode. And now I'm going to do arc sine of 0.3. Go back to my calculator. Okay, so first let's check out my mode. So I'm going to hit the mode button right there. And if you look down, I am in radian mode. So if you're in degree mode, all you have to do is highlight over to radian, hit enter, and then you can quit out of that screen by hitting second mode again, which is quit. All right, there is no arc sine, but there is a sine inverse. So if you look, sine inverse is located right above sine. It's in blue. So that means I have to hit my blue button to get it, which is my second button. So I'm going to hit second and then the sine button. That's sine inverse of 0.3. Close my parentheses, hit enter. And in pre-calc, when we are rounding answers, because I am going to obviously have to round this, we use 3 decimal places always unless it's money or people. Because if it's people, we use a whole number. So this is 0.305. All right, next one, tangent inverse of -4. I'm going to go back to my calculator. So this is just making sure you know how to use your calculator with it. Tangent inverse of -4. Negative 1.326. Negative 1.326. All right, last one, cosine inverse of 8. Go back to my calculator. Cosine inverse of 8. Close parentheses, hit enter, and I get error. And it actually tells me what kind of error. domain. Domain, remember, is your input. It's saying there's an error on your input. So please don't put like error here. We're going to say that this is not possible. It's telling me it's not possible because of this input right here. The domain of cosine inverse is all values in between -1 and 1, and 8 is not there. So reason why is because 8 is not in the domain. Ooh, is not in the domain. The domain is -1 to 1. And it's not in cosine inverse's